So hi, hello, and welcome again. Microbehunter here. I'm Oliver. Yeah, today this is not a microbe. It's actually a brine shrimp with the name Artemia salina. It's the larva stage, and essentially it's better known also as the so-called as the sea monkeys. I've got a whole bag of these seeds, not seeds, eggs. They don't come out of seeds, obviously. The eggs, and I tried to grow them. Unfortunately, not a lot of them actually hatched. A few years ago, there were many more, but I'm at least happy that a few of them came out. And now I basically put them under the microscope, and I hope that some of them are going to survive. Essentially, they have a very short lifespan. If you're lucky, if you're just able to keep them for a few days, and I've seen that over the last couple of days, some of them already died. You have to add a little bit more food, but in any case, hatching those sea monkeys is fairly easy. All you need to do is add a little bit of some of these eggs to some water, non-chlorinated water, of course, and usually the mix also contains already some salt because actually they do not like fresh water. They're marine water, salt water. Yeah, this round thing that you see over there, that is an egg. Okay, so now the question that is now the following is how can you actually increase the probability of them hatching? First of all, the eggs have to be stored properly. Obviously, I did do that. Still, oh, there's a second one over there. Oh, this one is even younger. That's nice. Okay, so some of them actually seem to have hatched a little bit earlier. And the other thing is that you need to get the salt concentration correct. And I think that's the biggest difficulty because when you are taking the sample out of the bag, I will show this to you later, then the eggs and the salt are not evenly distributed. And depending a little bit on how much you take out and from which part you take it out, you might get more or less salt. And I think adjusting the salt concentration, however, is one of those important things. So before I show you that, I would like to change a little bit the technique here. Yeah, I'm now in DIC and increase the magnification here. Looks a little bit nicer. I don't know. I'm not using a cover glass. It's directly on a microscope slide, and therefore it has maximum movement, but also the water evaporates. And as the water evaporates, the movement is, of course, limited because the film, the water layer is not very thick anymore, so it has some problems swimming forward. Yeah, very actively moving. And as a matter of fact, those brine shrimp are used also as fish food. So they're not just for hobbyists or for children, but actually they are being grown. Yeah, if you have an aquarium at home, then you can do that as well. And yeah, they're quite a nice little microscopic specimen to observe. I'm not going to show you a little bit how I actually got them. Yeah, they came in a pack, as I mentioned, together with salt, and I used a spatula, a tiny spoonful of the mix, and then added it to 20 milliliters of water, of tap water, and then you have to wait around a day. I had to wait 2 days. It also depends a little bit on the ambient temperature, and basically maybe around 10 of them hatched in here. You can, if you look carefully, you can see them swim around a little bit. But considering the fact that there are hundreds and hundreds of eggs, the success rate, the yield was not really very high. So I do assume that many of those eggs are probably not alive anymore, right? But this actually shows that still after a couple of years, it's still at least a few of them are able to hatch. Storage temperature is important. Moisture is of course also important, and then yeah. I think I'm just going to try to keep on repeating the experiment, the hatching experiment, and probably also adjusting the salt concentration. When you use table salt, you have to be a little bit careful that you use, of course, salt that does not contain any additives. But so basically, marine salt is best. And over here in this mix, of course, there was already some salt and some food present as well. So that's basically how it looks like. And let's put it also under the stereo microscope. Yeah, so this is now under the stereo microscope. If you look carefully, you can actually see some of them actually swim around a little bit. Yeah, there are definitely probably more than 10 overall in here. And as we've seen, due to the different size, some of them seem to have hatched earlier, some of them later, right? Let's go up a little bit with the magnification. Yeah, nice, nice and regular looking. Yeah. Here's this one. Yeah, difficult to focus, of course. Yeah, you get the idea. Yeah. But some of the eggs have a different color. I wonder why. Yeah, and maybe I'm able to also get this one here into focus a little bit more. Yeah, now they basically came in a pack like this here, right? Again, it's used essentially yeah, as fish food, as it says here. Now, when you look into it, then you're going to see that yeah, it's a mix of salt and those Artemia eggs, and because yeah, it kind of as you can see now, it kind of comes apart. The salt and the eggs, they have a different density and they separate, and therefore it's a little bit critical, I think, if you're scooping out the right amount of salt when you're preparing the culture. Otherwise, the salt concentration is not right. So I think this is something that one has to be a little bit yeah, aware of and make sure that it's evenly mixed before you take something out. Still plenty of them left in here. Yeah, so, but yeah, if you wait too long, they're not going to hatch anymore. All from my side. I wish you all the best, happy microbe hunting, and hope to see you in the next video. Bye bye.